Okay, here's a video about equations of lines in C3C4. Sorry, it's not going to be very exciting. I don't have any cool music because I'm just trying to do this video really fast. Okay, so let's start from the beginning. Here's what you know about lines so far. So if we had a line, let's make up an equation of a line, like y equals 2x plus 4. So just a normal straight line. Some things we know about this line are, we know the slope is 2, and we know the y-intercept's 4. So if I graphed this line, I know I have a point here, and then I know it's going up 2 over 1, rise over run. So my line looks like this, and I have a slope of 2 over 1. That's my rise, and that's my run. Okay, so I know that. I also know I can put this equation in another form, standard form, where I put everything on one side. So like 2x minus y plus 4 equals 0. So this would be called slope-intercept form. And this would be called standard form. And we now call both of these equations the scalar equation, now that we're in the vectors unit. So these are called scalar equations. Oops, I forgot the U. Scalar equations, and these lines are just in 2 space right now. So it's good to know that in 3 space we don't have scalar equations, we only deal with vector equations. So if we're just dealing with lines in 2 space, we know how to write them like this, and we know how to graph them. That's from grade 9 and 10. Okay, so now if we want to, let's actually just talk about one more thing. So if we wanted to determine if a point is on a line, so let's say I asked you, is the point 310 on this line? So just knowing what we know from grade 9, we know this stands for x and this stands for y. So if we just subbed it into our equation, okay, our left side would have to equal 10. That's our left side. And our right side would also have to equal 10. So let's see if that happens. 2 times x plus 4, and x is 3. 6 plus 4 is 10. So since our left side and our right side are equal, then yes, 310 is on the line. If I gave you another point, like 1, negative 5, and you subbed those points in, you would find out our left side is 1, and our right side is 2 times negative 5 plus 4. Which is negative 10 plus 4, which is negative 6. So no, that's not on the line. Okay, so we should know how to do all of that stuff right now. So let's extend our knowledge and do a vector equation. So it's another way to write an equation, and it's called a vector equation. And for a vector equation, we need to know a point on the line, and we need to know a direction vector. So this vector here is actually just going to be a point on our line. So if we had the same line, 2, 4, our R0 is just going to be a vector that goes from our origin to a point on our line. So we're looking for that vector. And then we're also looking for a direction vector. So we want a vector that's that's pretty much parallel to our line. Okay, so if we wanted to do it for the same equation here, then yeah, we pretty much already have the information we need. So a direction vector could be like the slope of the line. So we know our line's going over 1 up 2. So a direction vector could be just 1, 2, because that vector would look like this, 1, 2. So direction vector could be 1, 2, and a point, well, we know this point's on the line, 310. We also know the y-intercept of 0, 4 is on the line. So any of those points would work. So that's our direction vector. And we can figure out our direction vector using the slope. And we can also figure out our direction vector. Okay, sorry, so to do our direction vector, we can use the slope, or if you had 2 points on your line, so if you knew this point and this point, you could also figure out the vector between those points, because that would be the same direction. Okay, so using our information, I'll just use that point 310. Wait, is that what it was? 310? Yeah. So I'll use that point 310 for my vector equations. That's my point. And then for my direction vector, I'll just use the slope, 2 over 1. So that's a vector equation. And instead of an r here, I think you might see it written as like x comma y, just to show that we're kind of showing the coordinates. Okay, so that's our vector equation. We also know these things called parametric equations. And parametric equations are just when you break it up by x and y. So our parametric equations for this line would be x equals, and then we just take the x components. So 3 plus 1t, which I'm just going to write as t. And then for the y part, we just write it as y equals, and then we take the y part 10 and then 2t. So 10 plus 2t. So those are our parametric equations. If this was in 3 space, it would be exactly the same. It's just we'd have a z point also. So our parametric equation would also have a z equals spot here. And then symmetric, our symmetric equation is when we take our parametric equations and we isolate t. So for my top one, I'd have x minus 3 equals t if I moved the 3 over. For my bottom equation, I'd get y minus 10 equals 2t, so then I'd have to divide by 2. So if I isolated t in both of my parametric equations, I make my symmetric equations by, since I know the t's have to be the same value, I just make my equations equal to each other. And this would be my symmetric equation here. X minus 3 equals y minus 10 over 2. And then something cool to note is, we already know our scalar equations, but from the symmetric, you can go to the scalar equation of a line. So you can go back to it just by, I don't know, just like getting rid of your fractions in this equation. So if I have x minus 3 equals y minus 10 over 2, I want to get rid of the 2 on bottom. So I'm going to multiply both sides of my equation by 2. So those are going to cancel out. So I get 2x minus 6 equals y minus 10. And then I'll just move things around. So I get 2x minus y plus 4 equals 0. So this would be my scalar equation of my plane, which if you check it out in standard form, 2x minus y plus 4, 2x minus y plus 4 is the exact same. Or if I wanted to isolate y equals 2x plus 4, that's my slope intercept. Yeah, so you can see how to get from the scalar equation to the vector equation to the parametric to the symmetric and back to the scalar equation again. Okay, and yeah, important to note that if we had done this in 3 space, where we don't do symmetric equations in 3 space, or do we? No. And we're not going to do scalar equations. Oh, I think we can do symmetric, can't we? I'm crazy. Anyways, we're definitely not doing scalar equations. Okay, hope that helps. Oh, actually, I'll show you one more thing. Let's say we wanted to know if a point was on the line and we just had the vector equation. So we've got this equation for our line, 310 plus t, 1, 2. And we want to figure out if there's a certain point that's on that line. Okay, so sorry it's getting a little messy, but let's see, is the point, let's just pick a random point, like -1, 2. Is this point on the line? So if we just had our vector equation, what we could do is split it up into our parametric equations, which we already did, and then we could sub in these values for x and y. So we could actually sub in -1 equals 3 plus t and solve for t. So -1 minus 3 equals t, so -4 is equal to t. And then we do the same thing with y, so we'd sub in 2 equals 10 plus 2t and isolate t. So 2 minus 10 equals 2t, so -8, and then we're going to divide by 2 equals t, so -4 equals t. So we just proved that the point is on the line because our t values are the same. So t equals -4 in both of these. And if the point is on the line, they will have the same value for t. So that's a way to test it out in using our vector and parametric equations.